Hello to everyone. Welcome again. Yeah, uh, our SAT exam topic is functions and mathematical models. Yeah, here we are again. How are you? Yeah, for preparing SAT exam, we are here again. I love you all. Let's start with functions, okay? Thank you. This time, our topic is functions and mathematical models, okay? Functions and mathematical models. Mathematical models. Yeah. Let's start with function, okay? The definition of function. What's it? Let's look at this definition. Function. What's it? Y equal to fx is a mathematical relation. Where each element of the domain, very important, domain X produces at least one element of the range Y and no 2x values produce the same y value. Okay? Yeah, our definition is where each element of the domain X produces at least one element of the range. Okay? At least one element. But no 2x values produce the same y value. What's it? Yeah, we can give an example about function definition. Very simple example. Let's think that domain set are children, okay? Are children. Yeah, that's it. Children. Yeah. And our range is our moms. Okay? Yeah. Children Every children have one mother. Every children have one mother. But two children every children have one mother, but one children haven't got two different moms. It can't be. It can't be. It can't be. It can't be. How? These are children's. All children have mothers. All children have mothers. And these are mothers. But at least one element of the range. Yeah. For example, the important thing in this definition, one children can't have two mothers, okay? Can't have two mothers. This is the important point. This is the important point. Children's to mothers. You can think like that. So each element of the domain X produces at least one element of the range. Yeah, it can't go two mothers. It can't go two mothers. Yeah. For example, I will give an example to you. Like how? 1, 2, 3, and this is A, B, C. 1 goes here, 2 goes here, 3 goes C. Yeah, it can be a function. It can be a function. Or for example, 1 and 2 can go here. They are the children of A. Yes, it's normal. It's normal. And we have mothers that have no children. It can be normal. This is a function too. This is a function. This is a function. Yeah, it can be. Several different functions we must know. Which one? Several different functions we must know. First one is fx equal to x. Fx equal to x. Yeah. Fx equal to x. It passes through origin. Yeah, what's it? For example, this is fx equals to x square. Fx equals to x square, and this is fx x cube. It can be. They passes all through origin. Square root x, yeah, like this. Square root x, like this. And absolute value x. This is absolute value x. It can be. And this is 2x can be fx. Yeah, these are several different of functions. These are several different of functions, okay? And let me look. We have more examples, okay? For example, A, B, C, and this is 1, 3, 5, 7. Okay? Is it a function? Is it a function? We will look. This goes here, and this goes here. Is it a function? Is it a function? No. All elements of the domain, yeah, C, our C children have no mother. It can't be, not function, okay? It's not function. For example, A, B, C, and 1, 3, 5, 7. Is it a function? Is it a function? Is it a function? Yeah, it can be. It can be. Why? Think about my imagination. Children's and mothers, okay? Children A have mother 5. It can be. And B is children of 5. And C can be children of 5. It's normal. So it's a function, okay? It's a function. Let me look C, okay? A, B, C, and 1, 3, 5, 7. Let me look here. A goes 7, C goes 1, and B goes 3. Is it a function? Yes, it's a function too. Yes, it's a function. Why? All of our children goes to mothers. 5, our mother 5, name 5, have no children. It's normal. But in the domain set, all of elements must be must have mother. So another example. For example, this is A, this is B, and this is C, and 1, 3, 5, 7. A goes here. C, 3, and 5. And B goes 1. Okay? Is it a function? Our children C have 2 mothers. It can't be. Our C have 2 mothers. It can't be. Not function. Okay? Not function. Yeah. Not function. It's not a function. Do you understand? It's not a function. Not a function. Yeah. And we have another example. We have another example. Like what? Like what? Yeah. M 4, 6, 8, and N B C R K. Yeah. M to N. Which one is a function? Okay. Let me look. First one, 4C, 6K, 8B. Is it a function? Yeah, it's a function. It's a function. It's a function, yeah. And it's a function. Because all of our children, 4, 6, 8, have mothers, have different mothers, okay? And in second example, 6B, 8K, 4C, and 6R. Yeah. Is it a function? Yeah. All of our children have mothers, but 6 have 2 mothers. 6 have 2 mothers. So it can't be a function. Not function, okay? Not function. It's not a function. And third example related with this 4C, 6C, 8C. Yeah, is it a function? Yeah, all our children have one mother. Yeah, it can be. It can be. They are all children of C. It can be. It can be. So this is a function, okay? This is a function. Don't forget our imagination. Domain set are children's and range set are our mothers, okay? Yeah. And let's continue. Linear function, what's it? Linear function. Linear function, what's it? Linear function. What's the definition of linear function? It's a special type of function like m times x plus b, okay? It's a linear function. So its graph like a line. Its graph like a line, okay? Like this. It has a graph like this. Line mx plus b. Do you understand? On x-axis, it passes through x-axis and y-axis. Linear function. Yeah. M represents the slope of the line. Yeah. The slope of the line. M represents the slope of the line. Okay? And B represents y-intercept. Okay? Y-intercept. Yeah, that's okay. Where the graph crosses the y-axis, okay? Y-axis. This is very important. Yeah, let me do some examples for you. Okay, examples for you. Find the linear function. Okay, find the linear function fx given that f minus 2 10 and f3 is minus 5 okay. First, yeah, solution. Yeah, we have two ways. I think, from analytic geometry way and mathematical way. First way, let me look that in coordinate plane minus 2, 10, from analytic geometry we can think that 3 minus 5, because linear function have 2 points on the line, minus 2, 10 and 3 minus 5, okay? And then we can find the slope of, yeah, we can find the slope of this line, 10 minus 5 over minus 2 minus 3. Yeah, it's 15 over minus 5. So this is minus 3. So our linear equation is minus 3x plus what? Yeah, when you give minus 2, you must find 10. Or when you give 3, and then you must find minus 5, okay? We give minus 2, minus 3 times minus 2 is positive 6. So this is 4. So y is minus 3x plus 4. And in second way, we can think that it have an equation like that. fx m times x plus b, okay? So f minus 2 10 equals to minus 2m plus b, and minus 5 equals to 3m plus b. Yeah, let me find m and b. Subtract from this and this. Minus 5 minus 10 minus 15 is equals to 3m minus 2m, 5m. So m is minus 3. M is minus 3, and put wherever you like. Here 3 times minus 3 is minus 9. Minus 9 plus 4 equals to minus 5. So B is 4, okay? B is 4, and this is minus 3. So minus 3x plus 4 is our equation. Yeah. And about functions in SAT exam, the graph of a function can be shifted in coordinate plane, in the coordinate plane, okay? In the coordinate plane. There are some rules. For example, minus fx. What's it? Minus fx will flip the graph across x-axis. Across the x-axis. Don't forget. For example, f x plus h will shift the original graph to the graph original graph to the left h units, left h units. Yeah, this is what will shift the original graph to the right h units. Yeah. And what's that? Fx plus k will shift the original graph up k units. What's it? Fx minus k will shift the original graph down k units, okay? Yeah, very easy. Yes. So we can write here x decreases, okay? We can write here x increases. X increases. So we can write here y increases. Y increases. So y decreases, okay? Y decreases. I can show this. I can show this. You very good. We have very good example we can do. For example, look at here. fx x plus 4. Okay. What's our fx? We will look. X minus 4 and 4. Let's pass through here and here. You know how to draw the graph of this fx is equal to x plus 4. Yeah, we can do these. For example, f x minus 2, okay? What's it? We can do f x plus 2. We can do fx plus 2. Yeah, very good example. When we can do fx minus 2. Are you ready? So Mr. Tuna shows you that this graph, what's happening? Yeah, fx minus 2. Yeah, right. As x minus 2. It's x plus 2, okay? X plus 2. This is x plus 2. This is x plus 6. And this is x plus 6 too. And this is x plus 2. So the original graph minus 4, 4. And this is this pass through from here. Do you understand? Minus 2, minus 4. This is 4. This is 2. Yeah. So its original graph to the right 2 units, okay? Original graph, we must shift the original graph to the right. No, x plus 2. Yeah, x minus 2. So yes, it's we shift the original graph to the right 2 units. Right, 2 units to the right. Minus 2 to the right 2 units. And second one goes to the left. Okay, goes to the left. Yeah, minus 6. This is 6. 4 minus 4. This is fx, and we shift the original graph to the left 2 units. And so it's easy that up 2 units, yes. Yeah. Up to 2 units. to the left, to the left, to the right, to the right, positive 6 minus 6 minus 4, 4, and down, and down. Minus 4, 4, 2, minus 2. It goes to down, okay? To the right, to the left, to up, to down. Very easy, very easy, very easy. This is very easy. And we have question that what must be done? What must be done? Done to the graph, to the graph of fx equals x cubed, to move it so that fx will be placed on top, placed on top, placed on top of the graph gx is minus x minus 2 cube minus 4. Yeah, fx must be, yeah, let me do this. Fx must be, yes, first it must be flipped across the x-axis, and then shifted right 2 units, shifted right 2 units, and then shifted down 4 units, shifted down 4 units. Yeah, let me apply x cubed, yeah, flipped across the x-axis, minus x cubed, shifted right 2 units, right, yeah, this, okay, and then shifted down 4 units, okay, yeah, completed, okay, very good. And how can we do these? For example, fx x squared plus 5. Yeah. What's f minus 3? What's f4? Okay. And what's f minus 1? What's it? And for example 2x plus 5x. What's f3? What is f minus 1? And what's f4? Okay, let me show you. And another example, fx x cubed minus 4x and gx is 2x plus 5. What's fg2? For example, fg2. Yeah, we can find all of them. This is minus 3 square, 9. 9 plus 5, okay? It's 14. 4 square, 16 plus 5, 21. Minus 1 square, 1 plus 5. This is 6. 3, 2 power 3. 5 times 3. 8 plus 15. This is 23. Minus 1. 2 minus 1. 5 times minus 1. This is 1 over 2. Minus 5. Yeah. This is minus 9 over 2. Yeah. And this is 2 power 4. 5 times 4. 16 plus 20 is 36. Like this. G2 is 9. And F9, 9 cube minus 4 times 9. It's 729 minus 36. It's 693. 693, I think. Yeah. And how can we find the domain and the range? Domain and range of functions, for example. Fx 5 minus x squared, okay? Domain, our domain is all real numbers. All real numbers, okay? All real numbers. And the range of us, x squared always be positive. X squared can be 0 or always positive. Minus x squared can be 0 or smaller than 0. And then plus 5 minus x squared plus 5. So fx is smaller or equal than 5. So our range is all real numbers less than or equal to 5. Equal to 5, okay? Yeah. Another example we have here. We can find this domain. What's the domain of this? Yeah, in square root, negative number can't be. So it's equal to 0 or greater than 0. X minus 3 must be equal or greater than 0. X is greater or equal than 3. Okay, and then domain is all real numbers greater than or equal to 3, okay? and range. What's our range? Square root can be is greater than 0 or equal than 0 always. So plus 4 yeah. So our range is all real numbers greater than or equal to 4. Okay, yeah, we can continue. Example 1 over x fx. Yeah, find the domain set of this function. Yes, domain all real numbers greater all real numbers greater except 0. Okay, the denominator of the fraction can't be 0. 1 over 0 undefined. 1 over 0 is undefined, so all real numbers except 0 greater except 0. As x takes on different values, it's impossible for fx 0. Yeah, as x takes on different values, it's impossible for fx is 0. Okay, and range all real numbers except 0. It can't be 0. Yeah, and then what's it? 1 over x. Yeah, like this, okay? Yeah, this 1 over x. Very important. This is very important. Yeah, and don't forget that functions and graph of functions can be used to model such real-life situations as economic growth, population growth, crop growth, bacterial growth, and decay of radioactive substance, and so forth. Okay, we have practice questions. Okay, practice questions. Yeah, let me answer. Find the slope of the linear function fx, given that f4, 8 and f minus 6 is equals to 2. First question. And second question, what must be done what must be done to the graph of square root x, move it on the top of graph that hx square x plus 3 minus 7. We can look at third one, fx 3x plus x square minus 4x, and then find f2. And fourth question, find the domain and range. Find the domain and range of fx minus x plus 4 minus 3. Okay, yeah, find the domain and the range set of fx minus absolute value x plus 4 minus 3. Yeah, find the slope of linear function fx given that f4 8, f minus 6 2. Yeah, from analytic geometry 4 8, we have 2 points a and b minus 6 2. Yeah, what's the slope of these 2 points on same line? 8 minus 2 over 4 minus 6. Okay, 6 over 10, 3 over 5. Yeah, from here we can find this 3 over 5. Yeah, 3 over 5. And second one, shifted left 3 units. Okay, shifted left 3 units, and down 7 units to move it on the top of the graph of hx. Okay, shifted left 3 units, down 7 units to move it on top of the graph of hx. Yeah, and third answer, yeah, let me apply 2 square 4 times 2, it's 8. Yeah, 9 plus 4 minus 8, it's equal to 5. Yeah, the answer of third question is 5. Okay, find the domain and range of this. Okay, so domain is all real numbers, I think, all real numbers, but the range is let me look. Okay, absolute value x plus 4 is equal to 0 or greater than 0. Okay, and multiply by minus. Yeah, the inequality turns and change its sign. Yeah, and plus minus 3. So yeah, fx is equal or smaller than 3. So the range all numbers all numbers less than or equal to -3. Yeah, very good. Thank you for listening, Mr. Tuna. If you like our mathematic lessons, please subscribe my video channel. I love you all for preparing SAT exam. See you soon. Goodbye.